here is actually, yeah. Let's do one example of this. So let's negate a universal quantifier now. So how to negate our universal conditional statement of it? So if we have our statement is, who's got a good universal conditional? I'm tired of coming up with them. Actually, I'm not. I love it. But let's try to personalize this. Who's got one for me? So universal conditional, right? It's the for all x. It's saying it's like for all x and something, x does this implies x does this. What do you guys want? You're gonna force my hand. I'm doing it. For all students, if they're asked to make a universal conditional statement, then they pretend they're gone until I go away. They stay silent. I didn't want to have to do that. Do want to have to call you out? No, I'm not going to do that. That one's just too long to write down. What if we say like for all?
I got you.
What's up?
All right, I'm not gonna stay silent on this one. For all LeBron haters, they are a Jordan stan. I don't know if that works, but
They are.
I know the first part does.
Jordan what?
Stan.
Stan. Oh, fan. Oh yeah. So this right now, we've written it. This is just a universal. They say they're a Jordan fan. This is just a universal statement. There's no conditional yet. Remember how we can make universal statements from universal conditional statements? We just kind of restricted the domain and got rid of the arrow. We can also do the opposite. We can make the domain bigger and include an arrow. So I like this. It doesn't matter if it's true or not. For all x in people, x loves or hates LeBron implies x loves Jordan. I like it. So that's a statement. So how do we negate this statement is the question. Doesn't matter if it's true or not. Safa, you think it's true?
Yeah.
Maybe unless you live in Cleveland. Maybe we should put for all x and people except Cleveland. Although they've kind of come around to LeBron, right? I mean, he came back, got him a championship. That's enough. The point is, yes. So for all people that hate LeBron, X love Jordan, it doesn't really matter what it means for all people that don't know basketball at all. The only thing is, the point is, how would you negate it? What's the opposite of saying this? Well, first of all, this is already basically in math. So you just do that, make it in math. So then the opposite of that's saying what?
There are some people.
Yep, there's some person, or there exists a person, right? So
Yeah.
there exists an X in person, but you're totally right. That means there's some guy, some person, such that. Ooh. Now is where we run into a little bit of a wall. Because before we just kind of said not P. But how do you negate a conditional again? What's the negation of P implies Q? Now this one, I think we went over this a long time ago. That was like a week and a half ago. But it's a long time in this class though. I mean, this class moves quick. I think how far I've come. The point is, I think you guys might remember what this is not. This is not the converse. This is not the inverse. This is not the contrapositive. But do you remember?
Is it P and not Q?
Say it again.
Is it P and not Q?
Yes. Nailed it. It's P and not Q, right? Because the opposite of saying if P happens, Q happens is saying that P happens and Q doesn't happen. That's the opposite, right? That's the only row in the truth table that's false. So the only row in the truth table is false is the one where you have P, but Q does not follow. Because otherwise you're vacuously true or P and Q are true, in which case that's fine. So yeah, totally right, totally right. This is the opposite of this. So applying it to here, so what we really want to do is the negation of X hates LeBron implies X loves Jordan. But what that really is there is an X in people such that, how would you write this? So it's the P and not Q thing, such that X hates LeBron and does not love Jordan. Regardless if it's true or false, this is how you do it. Does that make sense? And this should make sense in our heads too, right? Like we just got this in math, just following the rules, or not really rules, following the results that we proved with truth tables and stuff. We just kind of followed the math and we got to here, right? But this should make sense. The opposite of saying for all people that hate LeBron, they love Jordan, is there exists some person that hates LeBron and doesn't love Jordan. Right? Makes total sense. So that should line up with our intuition. Anyway, in general, what we have is this. The negation of for all X and D, P of X implies Q of X. This, remember, is just a universal statement. This is just a universal statement. So we can first of all apply this, where this is the predicate. And so when this is the predicate, we get, okay, that means there exists an X in the domain such that not the predicate, not P of X implies Q of X, right? We're just plugging this in for that, right? But then this is equivalent to there exists an X in D such that P of X and not Q of X. That's a general form. So this is exactly why when we disprove a for all statement, where we disprove that universal conditional, like the SpongeBob example, we found an example, a counter example, right? Because that's how you prove something exists. You just find an example. Any questions?